Hey everybody, welcome back to Texas Reloading Room. I apologize for the lack of videos over the last couple of weeks. I have been recording, but my recording hardware has been giving me some issues. Today is Monday, the 19th, I think. Monday the 19th. And came into the shop today to do a little bit of off-brand work. What I'm trying to do with my shop when I'm not working on firearms, I'm trying to diversify a little bit and make some other things that are applicable to other industries. And what I'm actually going to be working on is making some of these. This is basically it's a lever handle that'll help people tighten their canning lids down if they have an all-American canner. So that's what this is designed for. There's been a decent amount of interest in this. I think they'll sell well. Still working on streamlining the production of these, but this prototype took about 8 hours to make. And rather than make this out of one solid piece of metal, which is what this is, I'm actually using two pieces now. This is kind of how it's going to start out. This is actually two pieces. So I've got the handle threaded into the head. And the main reason for doing this is to actually make it so I can fit this 11-inch piece into a small flat rate box, which is only 8 inches wide, or 8.5 inches roughly. But so I've got a 5/8 by 24 internal thread here and a 5/8 24 external thread here. I'm actually cutting these with a die. This one I cut with single point because I don't have a die holder. I'm going to look through my scrap today and see if I've got enough to make a die holder for that particular die. It is a relatively large die on the circumference, so I'll see what I can do. But anyway, so basically what I'm doing is I'm taking this, which is about a 7/8 diameter piece of aluminum. This is 1.5 inch external diameter. The only thing left to do on this one really is to flatten here and then cut the slot for the actual screw head. If you look at this, this is a little bit exaggerated, but this is basically what the head of the screw looks like. So it's got a little thumb thing that looks like a wing nut on the top of it, and this is what you can just slip over, give it about half a turn after it's snugged down, and your canner will be good and sealed. Plus, those things are a little bit difficult to unscrew when you're done, so that'll help. And another thing I was considering too is maybe putting a wedge on the end of this to help pop the lid loose. The more purposes this tool can serve, the better it's going to be, and the more likely people will be to buy it. We are cutting these out of aluminum, so it is incredibly lightweight. This is probably a half a pound right here. But I want to make that die holder. It's going to make things a lot simpler because single point cutting threads, it takes time. Alright, so I got the first operation finished here. It'll go in there. There's really no slop. So now what I'm going to do is drill and tap the holes for the handles. And for that, I'm going to use this 5/16 by 18 tap and a 17/64 drill bit, which is the tap drill size for about 60% thread engagement on this 18 TPI thread. And this is just long enough I'll be able to drill it all the way through. So I'm going to set it up on my mill and get to drilling this. So I didn't show you the lathe op because it was just tedious and time consuming. I will, however, show you how I'm going to do this mill operation. I'm only going to use one parallel for this because we're going to have this handle offset a little bit towards the back here, and I want to be able to punch both holes all the way through. Now on a rounded edge like this, there's a couple different ways you can do this. What I like to do is bring my edge finder down to make sure that radius is going to allow me to get contact with the widest point, which I believe it will. Alternatively, if you can't do that, you can set your quill or your head or knee and lock it in place, and then move it around to the other side on the same height level. I'm going to lock my quill here, and in case something happens, I'm going to zero it. So we'll take an edge reading here and then move it over here to the same exact spot. Let me mark my Y, 0, Y0, and Z0. Right, there we are. I'm going to zero the X. Now let's come over here. And bring it back into Y0. Right there. And we'll test it again. Right there's my edge. So what I have now is 2.3356. Take my calculator. I'm going to do 2.3356 and divide that by 2. 1.1678. So I'll move that over to 1.1678 and 0 RX. And then we can edge find off of one of these surfaces if we want to. Ultimately, that's not incredibly important. If we were going for repeatability on the other side, we would definitely want to edge find here, but since I'm just drilling one hole, I don't have to worry about that. Now, a good practice in general is to spot drill anywhere you plan to put a hole. But it's especially important on a radius surface like this one. We'll put our spot there. And basically what that does is it's going to help our drill stay on point and keep it from walking around. So. Okay, there's one. And 2. All right. Now, if you want to, you can tap it in the mill. I'm just going to tap these 2 holes by hand. Okay, so I got the holes tapped, and the reason that I didn't show you doing that is because I don't want you to do what I did. There is one more hole that we need to put in this, and that's for the set screw that holds the die in place. Okay, so here is the die, and it looks like that set screw is positioned right in the center. So we have a width of 396. If I take that 396 and divide it by 2, that gives us 198, and that does look to be right about the center point of that. So if we come in 198, probably come in like 200, 201, since I drilled this to have a couple thou clearance on the face. Yeah, so we've got 6 thou clearance on the face. So if I come into like 200, 201 and put our set screw at 90 degrees, now let me figure out what kind of screw we're going to use. Most of what I have here in the shop are gunsmith screws. Have an 8x40 Philister screw here. And it sits in that slot good enough to hold this, and it should sit deep enough to give me some clearance. If not, I can counterbore that. But So we'll go with an 8x40 by 1/2 for the set screw. And we'll offset that by 202. Now before we get gung-ho, we need to figure out what the tap drill size is for 840. So I'm going to go here in the blue book to the end of the threading chapter and find 840. So 836 is in here, 840 is not. So I'm going to go on the high side of the 836, which is going to give me a number 29 drill bit. The number 29 is probably the most commonly used drill bit in my shop because I do a lot of like 836 and 840 holes. Once again, we're going to do a center drill here. Just to keep the bit from walking. And then load up this number 29. A little bit of cutting oil. Now for this hole, I am going to tap it in the mill here, so let me grab my tap guide and a tap handle. Now even though this little thing says stare it on the box, I am still going to check it to make sure that this tap is not canted to one side or the other. And basically what this does is it helps it stay lined up to the hole. A little bit of cutting fluid. I'm going to switch over and finish this by hand. So I've grabbed my other stare it handle. I like this one a little bit better, honestly. Refresh our rapid tap here and get at this hole. Alright, let's go clean this up and deburr it. Alright, so the moment of truth. Thread starts nice and good. And I just felt that index in there, so that's rock solid in there now. All we got to do is make the handles for it, and if you remember, I'm gonna have to refresh my memory. I believe it's a 5/16 by 18. And I don't need crazy handle strength on this. We're tapping aluminum rods. So anyway, so there's the basic body of it. It's holding that nice and good. Like I said, when I tightened that down, I felt this spin just a tiny bit to index into that screw. And yeah, so let's go back over to the lathe and cut the handles. Alright, so it's a new day, and before we cut, or right after we cut, I went over to the lathe to start working on making handles for the die holder, and for whatever reason it didn't go well. Maybe the fact that I was using aluminum, but anyway, for some reason I didn't get the threads cut on that. I opted to go to the hardware store because I needed some screws for another project, and I just decided to pick up some bolts. So we're just going to use it like this. Like I said, I really don't like taking the time to cut single point threads in something that is a relatively common thread. We cut single point on barrel threads because it is much more controllable. We can get tighter tolerances, but for something generic like a handle, I'm gonna use a die. So now that we got this done, I'm gonna come back over here to the lathe, and let's go ahead and make a handle for one of those assists that I was showing you, and we'll put this to the test. So since this doesn't need to be precise down to a specific measurement on the length, as long as it's at or under 8 inches, then we're perfectly fine. Alright, so here's the other one. You can see we're at about 7 7/8. Like I said, anything somewhere between 7.5 to 8 inches is going to be perfectly fine. The internal width of the box that we're shipping these in is about 8.5 inches, 8.25 inches. So this will lay flat in the box. Now if we wanted to make even more room, we could angle it up slightly and get the hypotenuse length versus the base length. But anyway, so this is a 1-inch round rod. We're going to take it down to 875, which is 7/8, and we're going to cut this thread 750 deep, and this outer diameter is going to be 625 for the 5/8 by 24 thread. And then we're going to cut a 125 thou relief in here with my parting tool. So relatively simple process. I'm going to secure this in. I'm going to face it really gently, and then I'm going to put a center in here, and we'll turn it down to length. So one more time, we'll check that my stick out is good. I got 8 1/4 stick out. I'm going to go a little bit more. Let's go to 8.5. Okay. Now this rod is not perfectly straight. This is an extruded aluminum rod. So having to turn down the diameter a little bit gives us an advantage. Okay, chattering a little more than I like, so I think what I'm going to do is I'm just going to go ahead and put my center in before I do anything else. See where we're at. 901. So let's dial in 20, 1, 2, 3, And it doesn't have to be exact for this, so we'll dial that in. I'm going to slow this down to the slowest feed settings. We'll clean that up a little bit. Where we're going to stop. So at my stopping point, I will set it up so that my dial makes less than a full turn, and when it hits 0, I know to stop. So we're going to go 90 thou in on the dial and then stop. So pull this back and see where we're at on these threads. I think we got a little ways to go, but I'm going to clean this up. Put some more oil on it. That's the end of the cut. Heck of a lot easier than doing the single point. Now let's see how the head will feel in there. So here's the reason that you don't want to use a die for critical tolerance. See how much that wobbles? That's no good. Not for something that needs to be tight. This is just this is a home use thing. And once you get it down to the end, it's nice and tight anyway. So let's go ahead and put our grooving tool in. We'll cut our thread relief and then we'll part this off, and then we'll stick it back in and face that. Make sure that our thread relief is going to do its job. And it is. Excellent. So I'm debating whether or not to put a counter bore in there for this. I don't think it's really necessary. It's one of those machinist things that most people might just not even care about. But so if we decide not to do any fancy features on the handle, then that's the way it's going to be. The next step is to cut this, and I got to draw a sheet up for that. Thanks for watching, guys. I know this was a little bit off topic for what you're kind of used to, but let's face it, I am not a manufacturer. I don't have a manufacturer's license, so I need to find ways for these machines to make me money in other ways besides just a random slide cut or a firing pin or something like that. So working on these. These can probably sell for $50 or $60 a piece. Once I get them fine-tuned, we're gonna run them in the market and see how they go. I've had some people who are interested already. They've told me that I should sell them, so we'll see. But I'm gonna go work on this a little bit more. I appreciate you guys watching. If you watch till the end, awesome. And the die holder that we made, it's kind of a coincidence really, because I was thinking about making one and then I went home that day and Quinn from Blondie Hacks had done a video that day on making a die holder, so I just I watched hers a little bit, see how she did things. Mine's not exactly the same, but it's close. So this stuff might actually get split into 2 videos, I'm not sure. So if you see the outro twice, then I decided to split this. There was a lot of video content, and so yeah. But as always, thanks for watching, guys. I hope that you learned a little bit, and if there's anything you want to see, just let me know. Hit the thumbs up button, subscribe to the channel if you haven't done so already, and I'll see you next time.